I want to start by thanking Louis for inviting me, and more importantly, thanking all the people who made this possible, what I'm going to talk about. I feel a little bit almost like an imposter standing here, because what I'm going to talk about is so much larger than STSC. It requires the CENIC team plays in a pivotal role here. We have colleagues in the Midwest. I want to call out James Deaton, who's been a longtime supporter all the way from when he was at GPN. And so from the Midwest to California to the East Coast, there are collaborators on this project all over the place. Right now, we are managing hardware at 84 institutions. So I want to thank all of those people who make this possible. And as you see me talk about it, remember it takes a village and then some, maybe a city, to make something like this possible. And so what is this? First of all, after I gave Louis the talk, AI Infrastructure for All, and then after I finished writing the talk, I realized this is about much more than just AI. And so you should, everywhere where you see AI here in this talk, you might want to replace it mentally with data, compute, and AI, because it is literally about bringing digital assets of these three types, data, compute, and AI, to the classroom. And I'll start by explaining why. So we're at the beginning of a revolution in education. And that revolution is driven by two realizations of outcomes. One is that there is a transition happening where students change from being a consumer of education to experiencing education. And I'll explain to you what I mean by this. It's basically about programming at the fingertips of every student, and simulations, data analytics, and visualizations of any topic being available to bring it into the classroom during the classroom, have the exercises that use data, et cetera, et cetera, et cetera. In addition to making that shift from consuming to participating and engaging, is that AI makes personalized tutoring before, during, and after the classroom possible. In fact, and that personalized attention, which fundamentally is the gold standard of higher education. I mean, the gold standard of higher education is a classroom with 4 students and an instructor where they discuss. And that has not changed in hundreds of years, right? And we're capable of bringing some of that back into the classroom by virtue of AI tutoring, that every single student in a 500,000 student classroom can actually have their personalized tutor by AI. It's like having a TA for every student, which would be totally impossible without AI. And I'm going to elaborate a little bit on this in the next few slides. When I think about when I don't teach anymore, the director of the San Diego Supercomputer Center is a full-time job. But when I was teaching, I would teach typically the incoming physics students. So I would have 300 students in a classroom, and basically I would call myself an edutainer. Because in a classroom of 300 people, part of your job description is entertainment, because it's the only way that you can possibly keep their attention. And if you don't have their attention, you're not going to communicate anything. And so students are currently consumers of PowerPoint presentations, or worse, endless math scribbles on blackboards. And that's the state of the art for a 300-class lecture hall. If you then ask yourself, how do we actually learn as human beings? The majority of us learn much better when we do rather than when we watch. I mean, a silly, dumb example is the engagement in a video game is so much better than the engagement watching a movie. And right now in education, we're watching movies effectively of lecturers being entertainers. And that change is made possible with Jupyter. Students do instead of watching the instructor perform. So Jupyter Notebook as a quote-unquote invention, which happened, I don't know, a decade or more ago, maybe 2 decades ago, I'm not 100% sure. That is the first stepping stone into this revolution, because it provides the student interactive access. They play and work and da-da-da-da-da-da. It's the engagement engine of modern education. Then next step is AI comes in only on top of that. And AI makes something very interesting possible. It makes many things interesting possible, but one of them that I like is that you can have classrooms where you can bring in programming exercises without the students having to learn programming first. Even a simple, relatively modest exposure, prior exposure to software programming allows an instructor to bring in programming as a tool in order to do stuff. And my favorite example is Carl Böttiger from UC Berkeley, who has an ecology class with 122 students. The ecology students, by and large, are not expert programmers by any stretch. And nevertheless, he asks them to visualize, make a 3D model of the Manhattan skyline, and they import 2 software packages into ChatGPT or equivalent. He does this on NRP on our platform with our AI models. And voila, after these 2 things are ingested as context, the students can produce that visualization via code that the AI spits out, and it can be used to advance the curriculum. And I want to stress here, this is not about teaching programming to students. It's about using programming to teach content to students. And that's the revolution. Next, you'll hear all about this from Ilkay in the next talk. The National Data Platform is a data platform built on top of NRP and CENIC AIR that I'm talking about here. And it allows you to have large-scale data processing as a classroom exercise in your classroom. You can do things that are like you bring in research topics into the classroom and can have the students analyze significant amounts of data in real time because they have compute and data infrastructure at their fingertips, with or without AI. And then finally, the emergence of AI tutors at UCSD, and I'll pick a few examples from UCSD. In fall 2025, UC San Diego rolled out multiple AI tutors across a number of different classes. I think it was like 12, 13 different courses where they all, across a wide range of subjects, where we rolled out AI tutors in all of these classes. And they all have in common that attention to individual students is given by the tutor, even in very large classes. And I'll give you an example in a moment. Interactivity to change from student as a consumer to students as a largely engaged participant is already given via Jupyter. So all of these, you have Jupyter as a tool, you have the call out to AI as a tool, and then you have the AI tutor as a tool in order for the students to be able to ask questions in real time or work with the students on programs, etc., etc. We expect that most lecture classes will offer personalized AI tutors before, during, and after the classroom in the future. I believe that this is the future of higher ed for large lecture classes. Not for every class. There will always be the gold standard of a few students with an instructor in a discussion around anything you want. But in addition to this, our hundreds to thousands of students' classes that we have will be run this way rather than the way that they're run now. And I want to give you one example, and I'm going to pick something that UCSD is now famous for, or infamous for, and that is lack of math education, admitting students that have a lack of math education. You may have seen this in the New York Times. We made the national news. And the numbers are daunting. First of all, between 70 and 80% of UC students require calculus for their degree completion. Now, at the same time, about 1/8 of our incoming class does not have the requirements in math, the knowledge in math, to even take calculus at UCSD. And out of that 1/8, there is a fraction of 70% that don't even have middle school math. And so UCSD has always had an entry exam of sorts in order to evaluate whether people are ready for calculus. That's been there forever. But the number of students that fail that entry exam has increased 30-fold since the beginning of the pandemic. And let's not go into where and why this comes. We then have created 2 math courses in order to, one, to pick them up at middle school, and one, to pick them up in high school, to bring them to calculus readiness. And those 2 courses, I'm going to focus on the second one, the one that gets you to calculus. And we've been teaching this in fall 24 and winter 25 with a failure rate. The students who took that class, failed that class, about half of them, 50% failure rate. That's a devastating thing. They're coming in, they have to do this remedial course, and then they fail that remedial course and have to do it again. And so in fall 25, we introduced something that is an AI tutor that we developed together with somebody at City College and a company called Würthwein. And that tutor was deployed for the first time, and it decreased the failure rate from 50% to 11.5%. It's a gigantic leap that shows the value of AI tutoring, personalized tutoring, because the Math 3B is a large lecture class, and if you don't have AI tutoring, half of the students fail. And that's so my key message here is more students learn more with personalized AI tutoring. And so the key message I want you to take home, because this is the driving force of everything else that you're going to hear about CENIC AIR. This is what drives, that's the value proposition at some level for bringing this to community colleges, to CSUs, to high schools, ultimately. And the humans learn better by doing than watching. That's just fact. Then digital assets in the classroom redefine what's possible. You can rearrange the curriculum in ways that you never could. With a piece of chalk on a blackboard, you can't do the kind of things that you can do now with the National Data Platform, with Jupyter, and with AI. And then more students learn more with personalized tutoring. Ideally, every student would have their personal human being as a tutor. That's not affordable. Nobody can organize education like that. And so, voila, here comes AI tutoring. So, and then my final statement is, colleges that fail to adopt these methods will go bankrupt. I predict that because in 10 years from now, nobody will want to have education anymore that doesn't provide you these 3 things fundamentally. And so it is essential that this is happening, because it is happening anyway, and it is essential that we make it possible for everybody to partake. And I'm going to now first show you that this can actually be done at scale. And as a summary of my next slide is that 1/3 of all graduates and 1/4 of undergrad students have taken at least one class with digital assets in the classroom in academic year 2025, the last full academic year we had at UC San Diego. So we're doing this today at a very large scale, and I'll tell you in a second. So in the academic year 25, 18,963 students were enrolled in classes that had digital assets in the classroom at UC San Diego. And I have here the specs of this, and it's 132 courses with 81 instructors across 8 schools at UCSD. Basically, and what you see here, this chart, is that we started this in 2017, way before ChatGPT, way before the AI revolution that we're looking at. And we've then been growing over time the enrollment numbers. Each bar is a quarter. We're in a quarter system. And at this point, the last quarter of AY25 had more than 7,000 students enrolled. And the colors are the different schools in UCSD. The bottom green is engineering. Then you have social sciences. Social sciences, of all places, is one of the drivers of this revolution at UCSD, partly because cognitive science, which is an ML discipline at UCSD, is an ML discipline. They've done machine learning courses on this platform since beginning. And the last thing I want to say about this is, if you look at who's not in here as a large bar, physical sciences, my own discipline, is not present yet. There are courses in physics that use this platform, but it's not a driver in the way these other schools are. So it's a reasonable prediction that this will even grow. In other words, we're not done yet. At UCSD, a quarter of the undergrads is not yet where we will end up. I don't know where we will end up, but maybe 1/3, maybe half, I don't know. And then I want to give you one example And I literally have a spreadsheet with the 132 courses that were taught. And then I read that spreadsheet and to figure out what's going on, what is actually happening. And then I ordered it, what's the largest class that we teach? And the largest class is machine learning for music. Who would have thought that, right? And it is taught to 1,500, it was taught to 1,523 students, and it uses the platform. And if you read the abstract of what the course does, of course, Google's your friend. I figured all this out with Google. And it is impossible to do this class. This class would not exist without this platform. Because how would you do application of machine learning to understand and generate music, and then have in week 10 musical performance? And so this is essential to having compute and GPUs in the classroom. Now I want to switch topics a little bit, switch gears a little bit, and talk to why is this a statewide problem? Why isn't this an issue for for individual colleges, and let them all figure it out? And some use Google, some use AWS, some use Vocarium, and any other provider. And the reason is that in California, we have a master plan for social mobility. And I don't know I can't remember how it's actually officially called. My take on it is the CA Master Plan of Social Mobility. Education creates social mobility anywhere in the country. And in California, it's organized in a contract with the governor, effectively. And the top is the numbers. The student population in California is dominated by community colleges. If you just go by the number, we want to work with the community colleges because that's where the action is. That's where the most students are enrolled. And then there's about 3 million students enrolled in public colleges in California. That is 15% of the entire country. There are 20 million students in college right now in the US. Then if you look, there is a commitment by the UC, by each of the UCs individually, that 30% of the incoming class will be transfer students. So at UCSD and every other UC, you have two admission streams. You have an admission stream that starts at fresh people, and you have an admission stream, how does it work? Freshmen, sophomore, juniors, as juniors in the third year. And so these two admission streams happen every year, and 30% of the total admission is as juniors from transfer students from community colleges. Say for the CSU, this is even larger, 50%. So in a way, you have this strange thing that there has to be curriculum alignment from the community colleges to the UCs and the CSU in such a way that the three systems are loosely coupled to each other. And as we bring digital assets to the classroom, we better bring digital assets in a coherent fashion to all classrooms at all community colleges, because otherwise the transfer students have a really, really hard time. And that is what I want to stress. That is, in fact, I want to stress that for me as a professor at UC San Diego, it is a self-interest to work with the community colleges, because this time, Louis said that I'm a faculty in data science. This year, AY26 was the first time that the Data Science Institute admitted transfer students. And we got about 100 transfer students that basically have to figure out how to make this work. And we want that the tools we use at UCSD are also available everywhere else so that this can be going relatively smoothly. And so, why doesn't every college in California offer this today? And the answer is money. And it's not just money, it is structural. Operations is expensive unless it is operations of infrastructure. And this is a room full of infrastructure people, so you understand this. Operations is expensive unless it is amortized across large scales. And so what CENIC AIR aspires ultimately is that we want to aggregate all of these operations into one centralized operations team. And that way, the operations for everybody is minimally expensive. If everybody goes out and tries to hire system administrators and cybersecurity people and support people and research people who train the faculty, if everybody ends up having to hire all these people, then everybody goes broke, because it doesn't make sense for institutions that aren't needing these people for other reasons, to have a large group of people to support this. We better centralize. And this is what CENIC AIR is designed to achieve. And the strategy is centralize activities that get cheaper with scale, decentralize when costs scale linearly with size. If I buy 2 pieces of equipment, it costs me twice as much as 1 piece of equipment. Therefore, everybody should own their own. It shouldn't be owned centralized. They should all invest themselves. And third, create a community of educators that share the same tools and can learn from each other to accelerate improvements in educational outcomes. It's ultimately about educational outcomes. I hope I have convinced you in the first few slides that this is actually driving better educational outcomes. And now it is about how to organize this so that we can afford it and that every single college in California can afford it and can own its own infrastructure. And I'll get back to the owning is really, really important. It's not enough that SDC operates this and SDC gets a huge grant from the state and we own the hardware. I really want these colleges themselves to own this. And we'll talk more about this. Now, I want to play with some numbers to get a sense of scale. If you take UCSD as a reference and then apply this blindly to the 3 million students in California, I predict, that there are 750,000 college students in California that need data, compute, and AI infrastructure in their classrooms. That's a very large number. If you do this for courses or infrastructure, how many GPUs we need, that is even more astounding numbers. There is 10,000 courses in California that need digital infrastructure. And if I take the 100 GPUs or so that we use for this at UCSD and extrapolate blindly, I predict 7,000 GPUs would be needed. That is an overestimate, admittedly, because at least at UCSD, the first 2 years requires less hardware than the second 2 years for the bachelor and requires less hardware than the grad students. So the actual is somewhere lower. I'm actually, if you push me, I would say there's about 1,500 GPUs needed, modern GPUs needed for all of California. And we can argue over that number. Now, CENIC AIR is doing this. CENIC AIR is motivated by everything that I've said up until now, and we're building that. And I'm going to talk at the very end about all of the collaterals that come out of this. And that while the killer app is education, because just follow the numbers. 3 million students, 2 million community colleges are all about education, right? And so if you follow the number, education is the killer app. And then research comes as a side effect, and work with industry comes as a side effect, and I'll talk about this later. I also wanted to make sure that there's a whole lot of different talks that reach different aspects of this at this conference, and I encourage you to visit this if what I'm saying sounds interesting. I want to start by walking you through what we actually offer. Obviously, first comes the network planning, engineering, operations, and outreach and coordination activities. That's what CENIC does. That's why CENIC is such an important partner. Next is what I already alluded to. Your responsibility at a college is buy the hardware, put it into a data center, rack it up, connect power, and connect networking, and then you hand us the key. We operate the operating system, everything from IPMI up, and if IPMI means nothing to you, everything from the console up, basically. We run the operating system. Then what do you get back? You get back a global scale Kubernetes network, a Kubernetes infrastructure where you can instantiate, you can bring up containers on anything you want. That's the bare infrastructure that comes back to you. Then on top of this, there are lots of software reuse. We have lots of templates of all kinds of things. We have templates for containers that you might find interesting with all kinds of things in it. And we have Jupyter. So we run a Jupyter hub. So you as an institution can start by using our Jupyter hub to use in your classrooms on our infrastructure or on the community's infrastructure. So you don't have to buy right away, and I'll say more about this in a second. Then we provide LLM as a service. in a funny way, don't quote me on this, and I probably shouldn't be saying this, we're sort of kind of competing a little with OpenAI. We basically provide what OpenAI provides you with, except that we don't provide proprietary models. We provide anything, we provide about half a dozen open models, and we pick them according to what we think is going to be the most popular. And then we see what use is, and we retire the least used and put a new one in. And sort of roughly half a dozen of them is what we support. We also offer to support your model research purposes, and we're doing that with a couple of people. Next, and very at the top of the stack in a sense, is NDP that you hear all of about from Ilkay, and so I won't say anything. Now, where's it deployed? This is a slide that I stole from Tom DeFanti, and he's going to have more details on this in his talk later. And this is some pictures and then words on who's actually got infrastructure already on the platform among the CSUs and CCCs. And I've left out the UCs. There's another slide like this in Tom's slide deck on the UCs. Then this here is by numbers. And I want to just focus on CENIC AIR includes more than 1,000 GPUs, almost 15,000 CPUs, and more than 10 petabyte of storage. So there's a lot of infrastructure already in place. Now, admittedly, some of these GPUs, I like to call it, it's a museum of NVIDIA, because we literally go back to, we have almost every GPU that NVIDIA offered public for sale since the 2080 Ti's. So we have a lot of gaming GPUs because for a long time that was the best bang for the buck. And then more recently we have a lot of L40s, A100s, H100s, now H200s, CENIC AIR Champions, I will skip this. And now I want to talk about what's a possible path for somebody that wasn't on the list and not yet engaged. And I think that maybe the best path is that some of your faculty start by exploring NLP as is by just getting an account. And in fact, the way this works is there is a pointer to training, a pointer to documentation, and we have a Zoom-based office hour every other week on Tuesday. In fact, there's an office hour tomorrow. If you want to skip out on CENIC and go to this office hour, you're welcome. So there's an office hour tomorrow at 10 a.m. Pacific. And then when you have sufficient interest established in the college, then go and knock yourself out, buy equipment and have us run it. Or buy equipment first and have us run it, and then bring your faculty later. Whether you do this bottoms up or top down, I would do it probably bottoms up, but you choose. And I want to give a shout out to Dongbu. Where is, I saw him earlier. Where's Dongbu? There we go. Dongbu will have a talk, will have a part of a presentation later where he's talking about CSUs San Bernardino and its community college engagement. And I saw the slides and thought they were wonderful. And I wanted to sort of flash a little. So CSUs San Bernardino is now engaging with its local community colleges to bring them to the platform. CSUs San Bernardino, together with San Diego State University, were probably the first two CSUs that we were engaged with. And at this point, they and Fullerton are probably the strongest CSUs on the platform. And so now let me switch. This, of course, is all the effort that we have funded right now is funded by the National Science Foundation. So this is actually part of a national program. So let me say a few words about where we are nationwide. And my first acknowledgement has to be that this is actually a global program, but given the current state of affairs in the US, we don't talk about global anymore, right? We're not doing anything outside the US. America first, and the fact that there's a map that goes beyond the US, let's just ignore this. And so anyway, another thing on this slide is I put in here a slide that the CENIC folks made for me, which shows the RENs. And it is really, really crucial to state that the relationship that we have with CENIC in California, We have similar relationships elsewhere, and the most important one is with GPN in the 7 states that GPN covers. So this is whatever we do here, we do elsewhere, and we're open to do this with basically any RAN in the country and replicate. And there is discussions. I think if I counted right, we are right now having managing hardware in POPs of 13 RANs. And so and there's 1,500 GPUs in the country, 1,000 in California, and right there that sets the scale of how important California is and how far California is ahead of the rest of the country in some way. And now I wanted to acknowledge that this is also a research platform, and as a research platform, there's a boatload of organizations that use the platform but are not in any way, shape, or form educational. LIGO doesn't do much education, or the LHC doesn't do much education. They're research organizations. And so when the next few slides that I'm going to show you is usage, where I subtracted all of these sets of people and only focus on institutions that actually do education. And so, voila, the left shows you California versus the rest of the US. And well, 2/3 of the infrastructure is owned by California. So obviously, the utilization in California of the total is much higher. And then there is a pie chart of the rest of the nation, and where it goes by states. And it's interesting. I know in some places who those are. In Missouri, it's actually the University of Missouri who's driving it, and they're using it for education. In New York, it's actually Memorial Sloan Kettering that's driving it, and they're using it for research. So it's a mixed bag of usage. And in Illinois, I believe it's the University of Illinois in Chicago that is driving it. And another thing is 10 million GPU hours is not a small number. And so if you it is even compatible with some of the big infrastructures in the nation. Now I want to switch a little bit to Jupyter, and this is I asked the technical folks to get me the top 10 by users, total number of users, and every one of these Jupyter hubs has a story that attaches to itself, and I've tried to bring them out on the slide. I'm not going to talk about this. Let me just call out one that I like particularly. There is the University of Oklahoma Library, who actually is a relatively early adopter of our infrastructure, and they're using it to offer to their university as a library offering Jupyter, offering AI capabilities, offering all of this stuff. And it's a sort of remarkable that the library is driving the use of an infrastructure for the entire campus, not just having books in the library. Then I wanted to zero in on just the first one. The first one is the Jupyter that we run. And to me, that has dual purpose. I am a firm believer of eat your own dog food. If you're providing something for anybody, you have to also operate that something that you're providing to anybody. And so in every project that I do, I try to make sure that if we're being a service provider, we must run one instance of that services that we provide to others. And so that we actually understand how to operate this. That's one reason. The other reason is that we do this as a catch-all so that every institution has Jupyter access without having to run Jupyter Hub themselves. So it's, if you want to think of it, it's an entry port for everybody else. And so let's use who's using the entry port. And this is the pie chart just for the last year. And last year's pie chart looked actually quite different. So SDSU, San Diego State University, is the dominant user by GPU hours on the Jupyter Hub that we run for the entire community. And then UC San Diego is on there, which until I saw that pie chart, I had no idea that this is actually happening. And I sort of asked around a little bit, and basically what's happening, UCSD has its own infrastructure that it runs just for education, separate from NRP. But as you've seen on my earlier slide, it's been so successful that the amount of hardware that's available there is no longer sufficient to satisfy UCSD's needs. So some of my colleagues who use NRP for research have moved their education activities on NRP rather than UCSD because there's more resources there. 100 GPUs, 1,500 GPUs. And then I want to talk a little bit about AI inference as a service on NRP. Tom has more information on this in his slide later, in his deck later. Let me just walk you a little bit through the numbers. I'm a physicist. I love numbers. And so, excuse me. So on the bottom down here, you can see the LLMs that we support. And these are the top 5. And you can sort of see more or less, and the y-axis is a number of tokens per month. This is for the last month, basically. And so NLP supports a range of models. The use of, in terms of tokens per month, so to speak, is dominated by California. Surprise, right? And then you go and ask yourself, who are the top users of the AI infrastructure? And amusingly enough, the #1 user is from Arizona State University. That was a surprise. And I show you what they do. And then #2 user is from Santa Cruz. In fact, Santa Cruz as an institution is the largest AI by tokens, which is also was a surprise to me. And then they have places like Gladstone Institute. I never heard of them. I didn't even know that they use our infrastructure. They're an outfit which is a research institution in health sciences in San Francisco. And so you go down, and the scale is 10 billion tokens per month is the largest user. Now, example project, that largest user is on the left here. And what does the faculty do? They're a video game R&D person. They use AI to develop and benchmark AI playing video games is the best that I can summarize what they're doing. And then on the other side, I took one of the Santa Cruz people with 2 billion tokens in that month. And this is about machine learning tools, humans in the loop, to address things like how does noisy data affect AI, And I have a few more of these, and I'm going to flip through them and leave it to you to look. And I'm going to read out to you their comments on this is stuff that we collect and actually ask people, why do you use this infrastructure? What's good and bad about it? And the feedback was, not many researchers get access to frontier models because there are labs to provide them, and so they don't stay caught up on the latest models and use cases. By getting them via NRP, they get these amazing models and really run with them and not feel limited to have to put in proposals to get a closed code plan. And that last part of the sentence, not have a threshold to jump over by writing a proposal, sending it to somebody to get something for free, is a key feature of NRP. Anybody who comes can get access. And then you just hunt for the resources that are there. If you don't own resources, you get a hunting license. And you get to knock yourself out, use whatever you can find, and use the infrastructure that is available. And there is the NRP service has been essential for this work, enacting processing large volumes. This is LMS, a judge evaluation system. And I think the third example is a library again. This library is basically digitizing a corpus of 190,000 pages of newspapers, historical newspapers, that they digitized on our platform as part of this project. And so that gets me to the last part. How am I doing with time? We're good? So the last part is, I've spent almost the entire talk about education. It's almost like I made a little bit of a make-believe, because truth be told, if you look in the proposal that we sent to the NSF when we got the award and do a regular expression search for education, you will not find it. And so we created this infrastructure with a big R, research, national research platform. And we had no clue that this was useful for education when we proposed it, when we initially built it. And the education use case, in a way, is following your nose and following the data. So if we had done our homework when we made the proposals, we would have realized, oh, gee, 3 million people, And out of those 3 million, 2 million are at community colleges, and then another 500,000 at the CSUs, basically 2- and 4-year colleges. And the research-intensive institutions are basically negligible in terms of student count. So it becomes obvious that education is the killer app. And so in a funny way, our proposal did not include education. Our proposal also did not include that we would be running LLMs. There was not a word about LLM as a service. We ended up there because the proposal, by its structure, was flexible enough to be agile. And we had elements in that proposal that allowed us to do all this. And then we adjusted. And I think that is the plan, ultimately, of CENIC AIR, of NRP, adjust to where the needs go. And you guys, the community, ultimately drive what we do. We just happen to be watching out for where the technology goes. And so I want to say a little bit of research engagement with industry, because that's another thing that is not in the proposal. We had no idea that this is actually an incredibly powerful platform to enable colleges all over the country to work with their local industry. And in fact, Joy and Louis taught us the lesson. And you'll see Louis one day came to Tom, would you be interested in working on digitizing a vineyard in Sonoma? And so, of course, yes. And then that sort of made the ball rolling. And Joy hosted us. And I had the pleasure of drinking bubbly at Joy's vineyard. And a very good bubbly, by the way. And then that sort of got it all started. And so we now, having seen that this can be done, it now becomes an aspiration of doing this everywhere in California. And not just with vineyards, but with anything that you guys want to do. So my objective here now is I aspire that we create research capacity and engagement between colleges and their local industry. Because when I listen to the decision makers, to the CIOs, and basically the management layer of CSUs and community colleges, I hear something that I don't hear from my chancellor at UCSD. I hear a great desire to be relevant to their local industries. I had a meeting with the folks from Monterey, where the CIO actually told me these are the 3 industries that are relevant to my college. And that is our mission. If I go to my chancellor or my CIO, you're not going to hear these are the 3 industries in San Diego that is our mission. Because UCSD has no such San Diego mission. Yeah, we do some stuff with San Diego, but it is a national and global mission for the UCs. And so in a very, very concrete way, the CSUs and the community colleges drive, as part of their mission, the local industries. There's a local impact. And having learned this from Joy and Louis, it makes perfect sense to me, and this must be part of the killer app discussion for NRP and CENIC AIR in the future, that we will engage via you guys, the colleges, with your local industries, and we figure out together how we can provide value. And so let me flash a little bit the Iron Horse Vineyards in Sonoma. And this is in detail in a separate, and I'm going to start by Louis's. I took this slide from your talk, Joy and Tom, and it's according to Joy and Tom, this is Louis's goals, and I focused on 2 of those goals, which is involve community college, university faculty, and students. That's exactly what we want to do. And then another one, inspire other test beds in precision agriculture and perhaps among other enterprises. And that is where I am promising to every CSU and community college in California that if you have local industries that you want to work with on AI, on the infrastructure that you own, then call us up. We help. And that's really, really important that this is within scope. And I actually, the folks in Fresno, is anybody from Fresno here? The folks in Fresno pushed that button because Fresno is bringing up hardware that is partially owned by F3I. Now I'm going to mess this up. Farms Food Future. And Farms Food Future is an organization dedicated to startups in agtech. So CENIC AIR now has hardware that is owned by an organization dedicated to work with industry in agtech. Now, I went to the NSF. Bao was very, very worried that I wouldn't be allowed to do this, and she wanted it in writing. So I went to my bosses at the NSF, proposed a policy that allows us to do this up to a certain level. We agreed on the total amount of industry involvement that we're allowed to do for free. And beyond this, industry has to pay. And so we now have a policy written that the NSF has signed off on, that I sent to Bao so that she feels comfortable to bring industry money, so to speak, onto the infrastructure and industry interest onto the infrastructure. So we're now capable of actually doing all of this and in style, so to speak. The NSF has signed off on this. Now, of course, the obligatory picture of your vineyards. And then the obligatory pictures, eye candy, of Tom and John, and both of whom are in the room, putting blood, sweat, and tears into digitizing that vineyard and instrumenting. And there's a student right here, and I believe this is a student from Sonoma State. Is that right? Oh, that one's from a Berkeley student. And then there is, then I want to took one more slide from your talk, and because it speaks to what I've been talking about this entire talk. There is an end-to-end research pipeline, just like there is an end-to-end education pipeline at the highest layer of needs and sophistication. And that means, in this case, you capture the data in the vineyard, you bring it onto our infrastructure, onto Nautilus, onto CENIC AIR, and then you use NDP to curate it and to make it available to colleges as a push-button thing that Ilkay will talk more about. And that's sort of the conceptual. Then I'm at the end of my talk, and I want to remind you what I want you to take home as messages. Data, compute, and AI in the classroom drives a revolution in higher ed. And I hope that I've convinced you that that revolution is not about cost cutting. It's about improving outcomes, education outcomes. And I've given you all of the reasons why this is improving education outcomes. Because ultimately, we don't learn by watching as well as we learn by doing. And that is the most important thing. And secondly, we learn by individual attention better. More students learn more when they get individual attention. And we can only afford individual attention to students in a modern state university with thousands of students, 35,000 students going to 50-some thousand students at UCSD, if we don't do it by human labor, but by AI labor. And let me say one more thing about this whole AI story. I'm kind of a little bit annoyed that academia, AI, the fear of AI, all the bad things AI is doing to us in academia, is taking the air out of the room, that there's not enough effort, not enough brain power, not enough attention paid to all of the opportunities that we're getting from AI. I deliberately chose my examples in such a way that there's no question that there's nothing negative about a student who doesn't care about becoming a programmer shouldn't have to become a programmer just to participate in an ecology class. That is the power of AI. And you're not gonna, and all this hoopla about they're cheating and this and that and the other is just a temporary ailment, and we'll get over this. And it is really sad that that ailment takes out all the air out of the discussion around AI in academia today. And I want to encourage you to be creative and think about all the good that AI can be used for in order to improve student outcomes. And my prediction is that once we've figured out how to adjust to all the bad that we're struggling with right now, that will be forgotten. Because we will have adjusted, we'll figure it out. And all the good is what will stay with us, transformative into the future. Because it provides better education outcomes. So next one message is CENIC AIR allows every college in CA to participate in this revolution. And you know, if we didn't have CENIC, we would have to invent it, because there is the fact that CENIC connects all of these institutions of higher ed, and then from the higher ed into the high schools and the public libraries. And I'm actually interested in having that conversation. On the CENIC board meeting, Louis introduced me to people from the library community and people from K-12. And I think that we're ready right now to start working with the high schools and bringing them on board. And we're maybe ready to have a conversation with I sort of have a conceptual model in my head for how I could imagine working with the public libraries. The key problem and challenge with the public libraries is that you guys rightfully have an anonymity commitment, whereas we are forced by the feds to know every single person who accesses the infrastructure, and know people from certain countries and blah, 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 are allowed on the infrastructure. And so there is a mismatch here, that you're allowed to have an immigrant of whatever country walk into a library and use whatever you offer, and I'm not. I'm not allowed to do that. And so, but I think there is a way around this, and if somebody wants to explore this, let's talk. And then the last one is, I want to stress again that colleges owning stuff is really, really important, because the cost goes down. The total cost of ownership is my rough guide. The thing that I remember, and I verify this every so often with AWS pricing, it takes about renting a high-end piece of AI equipment, 100 days of renting, and you spend as much money as you spend buying it. We operate equipment 6, 7, 8 years. We have 5-year warranties. You do the math. There's an awful lot of difference in cost, that it is then all about how do we bring all the other costs down, and the dominant cost is labor. The other cost, other than buying the equipment, the dominant cost is labor. And we're bringing labor costs down. And so there is that's one reason. The next reason is home ownership, the analog to home ownership. If you rent an apartment and you lose your job, you lose your finances, you get evicted. The same is true for AI equipment. If you have a plan, I'm going to replace this after 5 years when the warranty runs out, and then 5 years happens and whoops, it's a bad fiscal year. If you have rented it, you're dead. It's gone. You've spent the money that you have allocated. If you own it, well, you run it a 6th year, and maybe the budget gets better, and a 7th year, and after 8 years it falls apart, and you have to do something. And so there is something inherently stabilizing about ownership. And the third reason is, while all of us who have an educational mission and our primary product is education, we can amortize costs on education cost. The only price that research finds acceptable, if you talk to any faculty, how much is it allowed to cost for your research? That's the price that they tell you. Infrastructure for research to first order has to be free. And how are you going to get free resources? Where does the money come from? If you own the infrastructure, then the spare cycles are there for research. If you look at how the education infrastructure looks like at UCSD, a quarter system means in week 1 and 2, in week 0, which is the week holidays, 0, 1, and 2, no use on the infrastructure. 8, 9, and 10, 100% utilized. So there is always a spare capacity for education, for research. And on top of it, you get research experiences for students, both within an industry context and within a research context. You create capability for your faculty to do research and for your students to research. And I'll leave it at that. Thank you very much.